Stanford built an AI that could out-diagnose doctors. It was better than most physicians at identifying life-threatening blood infections and, crucially, prescribing the right antibiotics. When it was tested against real patients, its treatment recommendations were rated as good as or better than infectious disease specialists. But it was never used on a single patient, not one. And the reason it failed isn't some kind of footnote in computer science history. What it is the exact mistake almost every company is, I think, about to make with generative AI right now in 2026. The system was called Mycin, and it was built at Stanford in the early to mid 1970s by a young researcher named Edward Shortliff. And it ran on about 5 to 600 hand-coded rules, and it could explain its own reasoning step by step. This was pretty much unheard of for software at the time. And if you look at the formal evaluations that it did, Mycin's prescribing recommendations were rated as acceptable about 65% of the time by independent expert reviewers. That's really competitive with, and in some comparisons, better than the actual physicians on staff. So by any technical measure, this worked. Why didn't a single hospital adopt it? It wasn't one reason. It was actually a stack of reasons. Firstly, doctors didn't trust handing authority to a machine. Nobody had solved the legal liability question. If Mycin was wrong, who got sued? There was no medical record system that was electronic to plug it into. So a clinician had to stop and manually answer dozens of questions by hand before getting an answer. And regulators had zero framework for software that practiced medicine. So overall, this was technically excellent, but organizationally homeless. It wasn't a smarter doctor that killed Mycin. It was the absence of a system that was built to receive it. 50 years later, swap expert system for generative AI and ask yourself, how different is the question companies are asking right now? Mostly it's one question repeated in every boardroom. How many jobs will AI replace? Reasonable question, probably the wrong one to lead with. The better question, the one that Mycin's failure points straight at, is what's actually stopping AI from changing how work gets done here? Because I think capability has never been the bottleneck. I think the bottleneck is integration. Let's take the clearest case that we've got right now, and that's software engineering. Modern AI coding tools can generate working code in literally minutes. That used to take us hours, and yet software engineers haven't disappeared. Job postings for developers, they've not collapsed. What's changed is the shape of the job. Less time typing code, probably more time reviewing it, testing it, deciding whether to trust it, and designing the systems around it. And there's a name for this. It comes from the theory of constraints, and that's an idea from manufacturing management. So every system has got one bottleneck at a time. And if you speed up the bottleneck, the constraint doesn't vanish. It just relocates to whatever was the next slowest step. If we think about this in the context of software, coding got faster. So now the constraint is verification. Can you trust what the model produced? And if we run that logic across other fields, the same pattern absolutely holds. In recruitment, the constraint shifts to assessment quality. Can a hiring manager actually judge what AI surfaced for them? In healthcare, trust and governance, exactly what killed Mycin in 1976. In customer service, it shifts to the edge cases, where a script can't actually anticipate what someone's going to say. Jobs were never single tasks you could automate away in one move. They're bundles of judgment, relationship, decisions. If you speed up one task in that bundle, you haven't deleted the job. What you've done is you've had to redesign it. This is the example that economists reach for again and again, and for good reason. The data is pretty uncomfortable for the automation kills jobs story. Economist James Besson ran the numbers. By the mid 2010s, roughly 400,000 ATMs had been installed across the US. Over that same period, bank teller employment had not fallen. It had actually grown from around 500,000 to nearly 600,000. Two things had happened. ATMs cut the cost of running a branch, so fewer bank tellers were needed per location. So the economics of opening a new branch actually improved. Banks responded by expanding. More branches meant more tellers overall. At the same time, the tellers who were retained weren't counting cash anymore. They were doing the things a machine couldn't do. They were building relationships, giving advice, and ultimately selling products. But here's the honest follow up, and I think a good script doesn't cherry pick. Bank teller employment did eventually fall, but not until years later, and not because of the ATM. It was the smartphone. Once mobile banking let customers skip the branch entirely, the job that the ATM had reshaped finally started shrinking. So the lesson isn't automation never costs jobs, it's the first wave that rarely does. It's usually the second complementary technology that finishes the job off. And I think that's worth sitting with given where we are with AI right now. This one is, I think, even wilder. There's a now pretty famous 1990 paper written by Stanford economist Paul David that documents it. When electric dynamos first replaced the steam engine in factories, productivity barely moved at all for about 3 decades. Why? Well, factory owners just swapped the power source and kept everything else identical. The same central drive shaft, the same belts and pulleys, all threading through the building. The same one size fits all layout. And that was designed around steam. The real gain only showed up once engineers figured out the unit drive idea, i.e., giving every machine its own small motor, which let factories redesign the entire floor plan. They could go single story, they could rearrange for the actual flow of work, and let individual workers control their own equipment. That required new factory architecture, new electrical engineering expertise, new ways of training and trusting workers. And none of that existed in 1900. It took until the 1920s to build it. The technology was ready decades before the organizations were. There's a really good reason why pilots succeed and rollouts have a tendency to stall. And I don't think it's a mystery at all. AI systems are trained on clean data, and organizations are not. Every real company is a pile of exceptions. You've got departments doing things differently, managers improvising around broken policy, incomplete records, tribal knowledge that nobody bothered to write down. Researchers call the gap between works in the lab and works in production the last mile problem. And it's consistently the most expensive part of any deployment. It's a big part of why self-driving cars, which have been almost there for over a decade, still aren't ubiquitous, despite the enormous technical progress that we've seen. A demo is a controlled environment, and your organization is not one. So, what does work? Across organizations that are actually seeing returns from AI, the pattern isn't they bought the best model. It's that they treated it as an operating model problem, not as a procurement problem. What they did is they simplified the process before they chose to automate it. They fixed their data. They invested in training people to work with the system, not just developing it at them. They built governance, who's accountable when the AI is wrong, before they needed it. And they started from the human outcome that they wanted, and they worked backwards to where AI actually fits. And I think that last point matters more than it sounds. If your team is drowning in repetitive questions, the instinct is let's build a chatbot. And sometimes that is absolutely the right answer. But often the real problem is the documentation was bad, the process was unclear, or training was really inadequate. And a chatbot bolted on doesn't fix a broken process. It just answers questions badly faster. Put mice in the ATM and the factory dynamo side by side, and one pattern emerges. Major technology rarely deletes a job outright. It changes the economics of the job, and the organization has to rebuild around the new shape it's acquired. That rebuild is slow, and it is where the real fight is. ATMs didn't remove bank tellers, they removed cash handling and left relationship work. Electricity didn't remove factory workers. It took 30 years, a new floor plan, and a host of other changes before the value really showed up. Mycin didn't fail because it was bad at its job. It failed because hospitals hadn't actually built the liability, the workflow, or trust structures to actually receive it. AI is starting to follow the same script. The constraint was never really capability. So if you're inside an organization trying to figure out what AI actually means for you and your team, the Mycin question is the one worth asking first. Not, what can this replace? But instead, if this worked perfectly tomorrow, what in our process would still stop us from using it? And the answer is usually about people and not the model. The technology, in most cases, is already the easy part.